Hello again, it's Mr. Slonka to talk to you about Section 8.3. This is the second video in a 3-video series. So, on our next note page right here, what we want to do is we want to continue what we were talking about, which is to write a geometric sequence. And when we are writing our geometric sequence, what I'm going to do is I'm going to progressively give you less and less information, but still expect you to produce the same result for me. So instead of giving you a nice sequence or pattern of a couple of numbers in a row, this time what I'm going to do is I'm going to give you a little bit more abstract information. I'm going to tell you that I want a rule, and I'm only going to give you the ratio value, which is 3, and then I'm going to give you the third term, which is negative 18. So now I have two different ways to solve this problem, and I want to show them both to you. And you get to pick which way you like the most. So the first way is very formula-based. So we have our formula right here. an is equal to a1 times r to the n minus 1. This is the same formula that we got in the first video right here. And it has a lot of great things in it. So what you can do here is you can use the formula and plug in all of the information that you've been given. So your ratio value of 3 goes in for the r. Your a3 goes in for the n. And your negative 18 goes in for an. So we have all of our information in the right spots. So now what you can do is you'll notice that you have a formula that only has one variable in it, and you get to solve for that variable. So I'm going to focus my time and energy on this little chunk right here because it's got the most different numbers all kind of grouped together. I'm following the order of operations, and when I do that, I'm going to end up with 3 to the power of 2, and then 3 to the power of 2 is going to give me 9. Now I want to move that 9 away from the a1, and when I do that, I'm going to divide, and that is going to give me an a1 value of negative 2. Cool. Now if you take a close look, whenever you're writing one of these rules, you're supposed to have a1, which we now have down here, and you're supposed to have a ratio, which we now have right up here. So you should have enough information to write your rule. So we can do that. Now let's say you didn't like that technique. You're like, I don't really love the formula, or I just don't like the way that the problem is set up. Let me show you a different way that will make it a little bit more similar to what we did on the front page. Here what I have is I've taken a couple of moments to write out my list the best that I have. So right here what I'm going to do is I'd be interested to know what A1 is, but I don't. It is a mystery to me at this point. I'd also like to know what A2 is, but I don't know that either. But I do know A3. So what I've done here is I've started at A1 and I've counted all the way down to the term that I have, which happens to be A3. Now what you can do is you can remember how a ratio works. Once again, the definition for a ratio is it's the number that you multiply to get from one term to the next. And so if we were trying to work our way down our list, what we would do is we would use our ratio, and we would use it a second time, and that would get us to the bottom of our list. Now we happen to know that our ratio value right here is 3, and so the number that we would use to bounce from one term to the next would be 3. Now, the other thing to note here is what we're really trying to do is we're actually trying to bounce our way up our list. So we're trying to get from the third term back to the first. So rather than multiplying by the ratio, what I would recommend that you do is divide by it, just like we did on the other sheet when we worked from right to left. So that means that if you take your negative 18 that's down there at the bottom of our list, and if we divide it by 3, that will give us negative 6. And that would be the second term. Now, if you divide that one by 3 again, you will get negative 2, and that is now the first term. So both techniques provided us with a negative 2, but they did it in two different ways. I like the first way because I know it very well and I'm very fast at it. You might like the second way because it's a little bit more straightforward, or maybe it just feels better to you. Regardless of whatever technique you're going to use, the answer is going to be the same. Our rule for this problem is going to start with an, just like all of our rules. It's going to have our first term, which we just came up with, which is negative 2. It will also use our ratio from the very beginning of the problem. And we're going to use our variable, which is going to be n minus 1. Let's try one that's even more abstract than that. So right down here, what we have is we have a problem that's even going to take it a bit further. Once again, like I said, I'm going to give you less and less, but expect you to produce the same. We still want a rule, but this time what I'm going to do is I'm going to give you A2 and A7. Now, neither of these pieces of information are particularly helpful. Once again, our formula requires that we know the first term, which we do not, and the ratio, which we also do not know. So in order to deal with this situation, I'm going to go back to making my list. Here's a list that starts with A1, and I really wish I knew what it was, but I don't. And then what I'm going to do is I'm going to have A2, which I do know. I'm going to have a bunch of terms that I don't know, and then down here at the bottom I'm going to have A7, which I know as well. As we've talked about a couple of times, when you're working from one term to the next, the thing that you're going to want to use is you're going to want to use the ratio. The ratio is called a common ratio because it's always the same, and every time you use it, it's a consistent similar number. So that works out really well. So let's talk about something. If we wanted to start here at the second term, how many ratios would you have to use to get down to the seventh term? Now I've drawn it out right here so you can actually count them. 1, 2, 3, 4, 5. 5 ratios would get you from the second term to the seventh term. I want you to notice that that 5 ratios is also the same as 7 take away 2. So that is another way you can get that number of ratios. Let me write this all out for you in a little bit a different way. If you started here with the second term and you multiplied by 5 ratios, you would end up at the seventh term. Let's take that even further. Our second term actually is 10, so we can replace that A2 with a 10. And similar to that is our seventh term is actually negative 320, so we can replace that guy with a 320. Now let's talk about the r's. What we have right here is we've repeated our r many, many times, and so you need to replace that with something smaller and better as well. A lot of times people are going to say, oh, that's easy, that's 5r. But please make sure you pay attention to the fact that it is multiplication. So this is different from the arithmetics. Right here, because this is 5 r's that are being multiplied in a row, that is going to be times r to the 5th power. That's a little bit tricky for some people to remember that it's not 5r, but r to the 5th. So watch out for that. Okay, so now what we have another formula similar to the last time that we can solve. And when we solve this one, we're going to get r. I want you to notice that this is not the formula that I gave you on the first video. This is a new formula that we've kind of developed based off of our drawing right here. This is also kind of a special technique that they don't necessarily show you in the book. Okay, so let's see if we can solve our formula. We have some multiplication right here, so we're going to divide by 10 on both sides. When we do that, we're going to get r to the 5th is equal to negative 32. And then when we divide that guy right there, we're going to end up with our r value. Or sorry, not divide, I take it back. What we need to do is we need to get rid of that power of 5 right there. So you have two choices. Choice number 1 would be to take a 5th root. Now the problem is that you probably don't know where your 5th root button is on your calculator. So let's use something that we learned in our log chapter. The other choice that you have right here is you can also use an exponent that would represent the same thing as the 5th root. The best exponent for that would be a power of 1/5. So that is the choice that I would make. That's going to be the easiest for you to type in and work with. So that would be the way I would want you to go. That is going to give you an r value or a ratio value of negative 2. So that one right there is going to be the ratio that helps us bounce from one term to the next. Excellent. So that's actually one of the two things that we need. So now what you could do is you can actually use that ratio value and you can actually bounce your way back to the first term by using a negative 2. So that works out really, really nicely. Or, like we did in the last problem, you can also use the formula. So if we have our formula right here, an is equal to a1 times r to the n minus 1, you can take one of your two original values and plug it into the formula with your new r value. I like this way best because it's my preferred choice, but once again, you can bounce your way back with your negative 2 as well. So I'm going to choose to use just the first term because it's smaller, not because it's better or you have to use it. It's just because it's smaller and I like it. And I'm going to use my new ratio value that we just found out about. Now that first term that we knew, which was 10, is also the second term. And so that is going to be a 2 minus 1 in my exponent right here. Let's make my 2 look better. There we go. Okay, so now let's see if we can simplify a little bit, just like we did in the last problem. So we are going to take our ratio value, which is negative 2, and we need to raise it up to this power right here. That is going to be now negative 2 to the power of 1, and that is going to be 10 is equal to a1 times negative 2. I'm going to divide. And when I divide, I'm going to end up with negative 5 is equal to a1. There you go. Now we have all of the information that we need in order to write out our perfect rule. Our rule is going to use this first term and that ratio value. Let's take a look at what it's going to be. negative 5 times negative 2 to the power of n minus 1. So there's our final answer for that guy right there. There's a you try it problem down there at the bottom, and I'd like you to try that out. See if you can pause your video and give it a shot right now. Here's the answer for the you try it problem as well.